This is a video on spherical coordinates. The question states, find the volume of the solid inside the sphere x squared plus y squared plus z squared equals 1, and the cone z equals the square root of x squared plus y squared. So let's start by sketching a picture. I have my sphere and I have my cone. Because I have a sphere, I'm going to use spherical coordinates. Cones turn out to be nice also in spherical coordinates. So I'm going to put my little man so the feet are at the origin and the head kind of teeters along on this sphere. So rho is going to go from 0 where the feet are to the sphere, which is a rho equals 1. So rho is between 0 and 1. For theta, the little man can spin all the way around from 0 to 2 pi. So theta goes from 0 to 2 pi. For phi, that is the angle from 0 where the man is standing up and down to where the man leans all the way down to on the cone. So let's look at this cone. Z equals the square root of x squared plus y squared. I can square both sides and get z squared equals x squared plus y squared. I want spherical coordinates. So the trick here is add z squared to both sides so that the right-hand side is easy to work with. And I get 2z squared is equal to x squared plus y squared plus z squared. So the right-hand side is just rho squared. And for the left-hand side, remember z is rho times the cosine of phi. So I can say that 2z squared is 2 rho squared cosine squared phi. And remember, that was equal to rho squared. I can cancel the rho squareds by dividing by rho squared. Then I can divide by 2 and take a square root. And I get that cosine of phi is equal to 1 over root 2. And that happens when phi is pi over 4. So now I'm ready to set up the triple integral in spherical coordinates. I have that the volume is the triple integral. Theta goes from 0 to 2 pi. Phi goes from 0 to pi over 4. And rho goes from 0 to 1. Now, since we have spherical coordinates, we have to multiply through by a rho squared sine of phi. And since we're looking at the volume, we just have a d rho, d phi, d theta. So this isn't too hard of a triple integral to work out. But you can trust me, I did this with a calculator, and I got that this triple integral is equal to 2 minus the square root of 2 times pi over 3. And that's about equal to 0.613. And that's the volume of the solid inside the sphere and the cone. And that was 0.613, and I'm done with the problem.